continue with the scripting and the blueprints creation and defining some functions and the events in Unreal Engine 4. Most of the time, the blueprints are not that very different than the Unreal Engine 5, but I just checked some zero density with Unreal Engine 5 and it was crashing. So I will just continue with the Unreal Engine 4 right now, but it's the same concept. And after that, I think we can discuss about the lumen lighting, how it's calculated, and there are some differences like hardware and software ray tracing, and we can talk about it. And of course, we can talk about the creation of the concepts after it, and maybe a little bit lighting for the virtual studios, and hopefully we will finish it. So, I'm just going to create a new folder called Blueprints, and right-click on the content browser, and I will just create a blueprint class. And I'm going to choose actor in the blueprints. So BP for the prefix, and let's say a controller. Most of the time, we are using a single blueprint controller for the controlling all the stuffs. So we are just creating a central blueprint for it. As you can see, this is the blueprint actor, and we have some outliner in here that we can add some components to our blueprints, such as we can add some lights, we can add some meshes, or there are some another components that we can add. You can check the list in here, and let's check this way. As you can see, there are lots of components that we can add to our blueprints in here. But for the controller and for the basic scripting, we are just going to use some basic nodes for the starting. For example, we will switch over the event grab tab in here, and as you can see, there are 3 nodes in here. So one of them is event tick, which shouldn't be used all the time because it has a huge impact on our processors because it triggers the functions on every frame and with ticking. So we will just try to not use this one. We will try to avoid it. And this is the events actor begin overlap is responsible for like collision stuffs, for example, in the game of if another actor starts to begin overlap for this blueprint, for example, if we can add some trigger on this blueprint as components, and we can control is this actor overlaps with any other actor in the scene. So in virtual studios, we are mostly not using this one. So on the begin play node, we are going to use it most of the time, and also we can create some custom events like this. So we will create some custom events, and we will just call these events whenever we want. Or if we want to trigger anything, we will just call it, or we will define some functions in the blueprint, and we will expose it to the zero density reality engine, for example. I'm just right-clicking on the blueprints section in the event grab tab, and I will just type print string. As you can see, on our blueprint script, we just added a node called print string, and it's we can type a string type to, for example, we are using this one to debug. I will just compile it, and I will just find my BluePrint actor that I created on the content browser, and I'm just going to drag and drop to my scene and just press the play button. So as you can see, there was a hello text. Let me make it a little bit increase time to see it easily. So when I when I press the play button, it just directly triggers this print string node in just directly in the instance. So we can also see how it works. I am just going to select this BP controller at here on the debug filter side. And as you can see, when I press the play button and just play node just starts to trigger the events. So maybe I can add some more logic. Maybe we can use some delays for waiting time, and I will just simply type delay and like 5 seconds. And I will, after the 5 seconds, I will just, again, print string, and I just want to print a hello after the 5 seconds. We will just another trigger to print another string, for example. Hello again. So it's printed hello and delay and hello again. So in the most of the time for the virtual scenes, we can hide the walls for our camera angles, or let's say we can just show some video walls, and we can control this video walls by their opacity on the material side. Let's create a new base material, and we will just try to control this material on the BluePrint side. We are just going to create a new material parameter collection. Let's call it ZD. And I will just define a new variable called opacity. And let's give it as a default 1. So when we started, we will just create another custom element to trigger it. But after all, we will just integrate it to a user interface that we can press the trigger, and it should be working after that. The basic idea will be behind the material. We are just created a material parameter collection that we can access this parameter everywhere we want, and we will just play with this variable with the functions easily. So I'm going to create a new material for me. It will be like video plane. I will adjust some texture on it, and I'm also going to change the material as translucent, so we can easily manipulate the opacity. So let's add a plane, and we will assign our material to this plane. Let's scale it a little bit. And I will just assign my material to here. So as you can see, we created our material, and we assigned it to our 3D objects. So we will just try to control this variable with a single custom element. So we created our material according to it because we are using material collection parameter right now to easily work with. Or we can directly work with the instances as well. And in the BluePrint event grab, be sure. Okay, I will just try to type a custom event. And as you can see, there is a node, and we can define a name on it. For example, we can say that disable opacity. So I will just add open with the left click timeline. So we have some buttons up there, and we can define a float, and we can define a vector which is called XYZ or RGB, and we can add some external events that will create another outputs for us. For example, we can say that trigger this event like the second on the second frame on the timeline, for example. So it just created a new key for us, and we can specify the time and the value of this key. So we were going to disable this opacity, for example. So for disabling it, we had to make sure that it's opened at the beginning. So it should be visible at the beginning. So I'm going to type 1 for our value. And by clicking this, I will just try to fit this screen. After that, maybe we can add some another value as 0, but let's say 2. So in the 2 seconds, it will go over 1 to 0, and we can define the total length of this timeline just editing the length of it in here. Also, we can define autoplay and loop, and there's a replicated, which is used for the multiplayer games. So we can also edit the curves. So, for example, like this, if we want to create a smooth transition. As you can see, we created our opacity in here, and our opacity just exposed in here. So for the material side, we are just going to set this value using material parameter collections. Set color parameter value will be enough for us. Yes, this is the node, and collection will be the actor that we have created on the content browser. And as you can see, our parameter name. So we will just get this opacity value, and we will assign it to our material collection parameter directly. So when we call disable opacity, it will just start to 1 to 0, and with each frame on this timeline, it will be updated by timeline, and our collection parameter is already connected with the material. So, for example, let's make a little scripting in here, and when the instance started, when we hit begin play, it just needs to wait a little bit, maybe with a delay node, and just call disable opacity that we have created. So when I double click, so it will just open my custom event that we have created. Let's just wait, and there you go. So I just want to show also execution logic behind it. As you can see, it just waits, and just directly triggers it. So it's the basics of the blueprint scripting actually. Also, we have some functions. For example, zero density uses these functions directly for the exposing to the broadcasting area, broadcasting user interface. When we created an actor, when we created a function on an actor that has some ZD component, for example, ZD component is just a unique component for the zero densities solution. But for example, for the Avid Maestro, we can add some extra functions, and we just need to expose it in their way. So zero density just works with adding by simply ZD component to our actor. But for the Vizarti works differently, and Maestro just works differently. And I think Maestro was just working with the typing some prefixes for the functions on the level blueprint. Also, we have a level blueprint that we can control and see all the actors on the outliner. So we can control all these actors on the level blueprint, or there are some other techniques that we can discuss in the future sessions. So we can get some object name easily, objects reference to the blueprints, or we can just create some functions and we will just throw them to the level blueprints easily. For example, we can just press this button to add function on the left side of the blueprints, and we can create a new function. For example, we can call it as height video wall function, for example. We will just try to expose it to the zero densities UI, for example. So what will happen if I try to call this timeline in here? I am not going to be able to add a timeline in here because function won't let me to do that. So luckily, we have created our custom events in the event graph directly, and we can call this custom event in our functions. I'm simply calling disable opacity custom events. So basically, this function will trigger this event. See, it just worked easily. Do you have any questions about the scripting for this part? Great. So let's try to use this function on the zero densities user interface. So for the controller, I will just press play and just try to open my reality. Now just check some ports. As you can see, this is the user interface of the zero densities UI. So it's also node-based compositing tool. It provides a node-based compositing tool. So we can have our AJA input and outputs in here, and we can switch our cameras in here, or we can just basically add some virtual cameras in here to check is it working well with the zero density solutions. For example, we can add some camera. And we can just basically play it. So we are not using the Unreal Engine's default camera right now. We have overridden the camera with a virtual one that's provided by Zero Density is Reality compositing tool. And we can play this. I will just try to use it like this. So we are using the Reality input. Type a name, like BP controller, and I'll just press play, and let's try to see is it worked. Yes, as you can see, it's when I added a ZD actor to my controller blueprint, it's just directly exposed to the UI for the Reality, and we have a function in here. As you can see, there are some properties for the selected blueprint actor. And if you check that, like let's eject the camera and we will just try to find. So let's check this location, the transform info. And we can all see all the transform info in here. So it means that we can change their location on the Zero Density's UI with the engine easily. Also, we have a function in here that we created on the blueprints, and when we basically just press it, it will trigger this function. So we can add some objects to our mesh like this, simply adding a cube. And we can, we will try to actually hide that wall with a single click. For example, let's pretend there's a camera and it's blocking our vision, and we are working in the virtual scene. So we might need to change that visibilities for us. For example, there's an angle that we liked, but something is blocked. So we can just filter these walls, and we can just simply tell that it's the right wall, it's the left wall. So when we just press the hide right walls, all of the right walls will go. And we can just convert it easily, so we can hide or show it again. So in order to do that, we will just simply add tags to our cube. For example, let's create 2 walls or 2 cubes in here, and I am just making sure that I am selecting it and adding some text. Each actor has some text. You can find them in here, or just you can search the details on this area, like just simply typing with tag. So let's say right walls. So we just categorized these meshes as right walls, and on my controller node, I'll just try to close them, and I am just going to add another function for hide right walls, for example, and I'm just copying it. We will use a node called get all actors with tag. So we will just try to fetch all the static meshes all the actors that we assigned a tag. So we will just select them and we will just disable it, basically. Gets all actors with tag. So our tag was right was, right? So right was. And all the actors will be. So this node basically will just try scan all the actors. Not very optimized, by the way, but it will just try to give me some meshes that I have assigned to tag that we have specified, basically. So it can return lots of actors, for example, and it can create a negative impact if there are thousands of the objects. And in this area, we just need to make sure that we are writing an optimized code because we don't want to see the hitches on the processor side. So other actors will return to us as an array. So it can contain multiple actors or the static meshes. So we are going to use for each loop to execute one of them. For example, we can create another custom events, and we can have some functions, for example, and by using for each loop, we will just get those actors from this array, and we can manipulate them easily by one. And array will be return me from index 0 to latest index. For example, we have 2 actors in here that we are going to get, and it will just return to us 2 index, but our indexes will be starting from the 0, and the second wall will be the 1. So just 1 minus 1, let's say, for the indexes. It will always start from the 0, not the 1. So it will return this meshes as 1 and the index 1, 0 and the 1, and we will just execute some events on it, like set visibility or actor hiding stuffs, and maybe we can type some custom functions, and we can call these functions for these meshes. We will just simply get root components because it will return us a actor, and we will try to get the root component of it, or maybe we can use cast to. So if the returned objects, if we know what will be the returned objects type, and it will be very good for us to optimize the code actually, because we can create some casts on it. For example, let's say we are going to return some hoods, so we can heads up display. We can just directly cast the hood for these meshes, and we will just directly get those references in the blueprints. But I think getting the root component will be enough, and if it's not working, we can just try to cast to any static mesh actors, and we will just work on it more and more. And set visibility, I think, will be the correct nodes, and we will try to hide it. So new visibility will be Boolean, will be false, and I think it should be working right now. So it will try to return the right walls actors who has this tag. We will execute them by one, and set visibility trigger for this returned components or the meshes or the actors. But it's totally up to our context. So I will just press play and I will just check it. Let's try it. I will call height right walls, and there you go. We just get all our actors, and we just simply make some operations like set visibility, and we just hide them. So we can duplicate these functions easily and create vice versa scenarios like show right walls, or we can simply change the actors text and we can manipulate them as we want. And also we can add some level sequencer text triggers on it, so we can add some motions to our actors, and we can do whatever we want with the scripting tool. So we can duplicate the functions that we have created for the hiding the right walls, and let's call it show right walls. And so I am also I am going to get the right walls again and make a for each loop operation on it, and just I am going to select with set visibility to true to make it visible. And let's play it, and we have created, we have duplicated our function, and hide and show. So according to our needings, for example, let's say that we have a good shot in here, but our objects is blocking us. So we can hide them for the specified engine, specified camera. So what will be happen if we play this timeline as reverse? So basically, it will start from the 0 and to 1. Let's create a new custom element for us and open opacity, let's say. And we will just reverse it from the end. And we can add another function in here and show video wall function. All of these functions will be exposed to the reality in order it will allow us to trigger on them in the zero densities UI, for example. Let's call open opacity. We just simply called this custom element in this function. I just check it, play button, and let's start with the show. It started from 0 to 1 and 1 to 0. As you can see, we just manipulated the opacity of this video wall or the material, let's say. I think we can have a break right now, so we will continue after this break. Thank you. Hopefully, we can, for example, create a election bars, for example, and we will just modify their height according to the incoming value, and we will make a basic calculations on it before the set the value of it. As you can see, there is a box, and I just created a merge targets for them, which is basically it's the same mesh but in a different height. So in the 3ds Max or the Maya or the softwares like Blender, we can easily add merge targets, and let me show you how it's done. So Here's my base mesh, and I will duplicate it, and in a different height, and I will just make it to convert the polygons. And for my base mesh, I will add Murpher modifier, and I will pick that height, another object for the Murph target. So, as you can see, there's a box 2, and when I increase the value, it will just create an interpolation between them, and it will be our base mesh for the bars, for example. I am just going to export this one as selecting export selected, and let's call it CK bar mesh. So in our Unreal Engine, I'll just try to remove them for my test objects. I'll import my exported bar mesh, for example, in here, and I am just going to hit skeletal mesh because we are going to import Murph targets that we have created in here, and import all. And as you can see, here's the base mesh, and we have a Murph target in our skeletal mesh editor. Basically, skeletal mesh editor consider as if any mesh has a bone on it and it has a skinning weight, it will consider as skeletal mesh. So it will just create a root bone for us when we imported a skeletal mesh. And we can play we can adjust the height on the skeletal mesh editor side. So basically, we will just manipulate these values with blueprints. This is the main idea of the elections. We will just go into with controller, for example. I will just add a skeletal mesh to my controller, but it's not a traditional one because we can create another blueprint actors for each bar, and after that we can send these values to the these blueprint bars easily. But for the main idea, I will just simply add that bar to my skeletal mesh to my blueprint actor that we have created for the controlling. For example, we will add skeletal mesh in here because we imported it as skeletal mesh, and I will just simply assign my skeletal mesh to here. So as you can see, here's our base mesh. So let's add a comment on it. For example, we can say video wall opacity, and I am just going to create another event for controlling this bar with the timeline. Custom events, play bar animation, maybe. I will just simply drag and drop my bar mesh in here, and also I'm going to add timeline, add bar merp, maybe, play from start, float, and we are going to control this bar value as with the value of float. So we are just going to use a variable type for the float for the height of it to adjust the height of the MERP base mesh. So that's why I am adding a float track for it. And let's say bar mesh, and we will add some curve in here. It will start 0, and 1 to 1. So in a 1 second, it will try to reach out to 1. And I am just getting this wire from here and simply type set merp targets. And it will ask us the merp target name. For example, for the merp targets, we can use for mouth animation, facial expressions for the 3D characters. So we can have multiple merp targets on it. But in our situation, we only added a single merp target in the 3ds Max to only control the height of it. So we will just provide the name of it, box 002, and also we can control this merp target's name in here. As you can see, there is a merp target name. Yes, you can see it. And box 002. And I will just directly give this value, as you can see here, 0 to 1 in 1 second. We will provide this info to our merp targets. And when we call this play bar animation custom element, it will just directly try to increase it. And let's add a function for it. We can say play bar anim and play bar animation, the name of our custom event, play bar animation. So on the zero density and reality engine side, we should see this controller, hopefully, and I think engine is not running right now. I will just provide the location to here to make it visible, and I will save my level and try to open zero density. I will just restart the Unreal Engine. It's not pinging the instance and server, so yes, here's our controller. And play bar animation. And as you can see, there is a issue, and this issue is related with the physics actor. So, because the default form of the physical boxes for the skeletal mesh isn't properly aligned for the height of it. So we will just open the skeletal bar mesh, and we will just try to find the physics assets that is imported, that is created while we are importing. And as you can see, there is a very small capsule, so we can increase it in this way. The idea in the elections, they will provide us the results with the, for example, JSON data structure. So we can simply feed these values for the merp targets, and it will just directly adjust it according to our height. So we can specify a higher limits as let's say 100 centimeters, and it will be our maximum, and we just need to make it clamp, set the maximum value of it, and we can basically just feed it with the set merp target. Also, we can create a new materials for it, and we can create some material colors for them. And for example, for an election, you can ask their party colors as RGB, and you can directly match these colors with the specified bars. For example, let's add a text render in here, and it can be like this. Sorry, I'm just doing it the wrong way. So this is a text. So each bar can contain a unique text bar, and basically you can print the party name, maybe, if you need, or the status of the voting. You can set or customize the text as you want. For example, let's create a new variable for us. On the left side, there's a variable button. So we can add some Boolean operations, which is returns true or false, or it can contain, as you can see, integer, string, name, vector, or there are lots of variables, as you can see in here. So each one is different. Each one has some unique their style. For example, there are some enumerations that you can define party names, for example. And there are lots of ways to do it, but I'm just showing only the one example, how to modify the datas and modify the variables. So, for example, let's start with the basics for the variables. For example, in our scenario, is data ready? It can be. So it will return us true or false according to this one. So it will return true, it will return false. So also when we have a variable, we can call it as get, or we can set it according to our needs. For example, let's say we are trying to read a JSON data and we just validated it is ready. So we can set it as true. Let's create a little simulation in here. I'm going to create a custom event. For example, it can be fetch JSON data election, maybe. And it will, after 3 seconds, it will mark it as data ready as true. So when we call this, it will just wait 3 seconds. And in here, for example, we can do our reading from the external data sources. Like, for example, we can create basically WebSocket servers, or we can directly HTTP request to get some data, or whatever we can do is also read the local files from the Excel, for example, and after that we can mark it as data ready. And we can control also this play bar animation with is the data ready, and play it. If the data is not ready, it's not validated, we won't play it, for example, with the basic Boolean checks. In order to do that, we can add branch, which is called if-else in the programming language. So it will try to, is it true? It will try to read, is it true or false? And if it's true, do, and if it's not true, if it's false, do this one. So if the data is ready, maybe we can play the animation that is given from the JSON structures directly to feed the value, or maybe can say that data is not ready. And it will be red color, and it should be much more visible when we add some duration to this text. So, for example, let's say that when we start to play, we will try to fetch JSON data election, and it will lead us to here, and it will try to mark it as 3 seconds. And when we try to play bar animation, it will check that is the data ready. If the data is ready, it will play the animation just with a constant value. But if it's not data not ready, if it returns false, we should be seeing this string on the screen. So since we are marking it as true after 3 seconds, we can easily see this execution of timeline and the set merge targets in a motion. And I am just going to show you, I will mark it as false, for example, in here, so it won't let me to play the animation. So it's false. Let's check it in here also. I just want to make sure that you can see it easily. So here's our logic. So nothing happens. Just try to play this. As you can see, it throws false. But if we check it as true, it should be playing directly. So this is the basics of the if-else in programming, actually. We can simply use branch to get this Boolean variable type, and according to the Boolean, we can do whatever we want. For example, I can give you much more examples like, how can I say, in a game, if you have a key, you can open the door. But if you don't have a key, you can basically say that, go and find the key. Of course, it's an example for the game programming, but this is behind the logic. Also, we can have another variables, like we can add some floats. For example, I would like to go on the examples for gaming because it's a huge area, so we can see how it's working in the real-life examples for game programming. I just want to create another BluePrint object. BP, let's say health. So most of the times in the games, you know that there are some healths. So if your health is too low, you can see some screen shakes or some screen effects. And if it's less than, for example, let's say 10, you will see the effects of bloat. And if it's 0, if it's equal to 0, or if it's less than 0 and equal, you can die, for example. And basically, this is the idea of dying in the games. Maybe they add some delays and they just respawn you in the games. So, for example, let's add a new variable in here. I just want to do it again. I'll just add a variable and call it as health. And we can make it float.